We are here again for another mini lecture. Last time we met, we finished up looking at the conus medullaris and the cauda equina. We're going to do a little more anatomy. If we look at the conus medullaris, which is right here, and what we're going to see is that coming off that conus medullaris is a single piece of pia mater. So there is a single piece of pia mater that stretches down from the spinal cord, from its end, the conus medullaris, and that single piece of pia mater, I don't need to update my recovery media right now, single piece of pia mater is called the filum terminale. Filum terminale, string at the end. It is this thing outlined right here. It is going to be anchored to the coccyx. It's going to be anchored to the coccyx, and it's going to give the spinal cord some inferior support. Okay, moving right along. Let's do the cross-sectional anatomy of the spinal cord. One thing we already covered is the fact that we've got this grayish butterfly. This gray butterfly is made of gray matter. We mentioned earlier its big job is integration. Now, because it's doing integration, its number one component, this is the most important part of it, so I'm going to circle it 4 times because it's like quadruple important, quintuple important. Somata, cell bodies are in that gray matter. We will also see dendrites, and we will see unmyelinated axons as well. Now, this region is gray because it doesn't have myelin. The white matter is outside of the gray. So white's outside of the gray. The white matter is made out of myelinated axons. We learned about it before already. These myelinated axons are carrying signals up the spinal cord. Those would be sensory signals. And down the spinal cord, those would be motor signals. Okay, what else do we see here? In the front of the spinal cord, there is this cleft here. I have labeled this cleft AMF. That stands for anterior median fissure. Fissure is a pretty deep groove. In the back, there is a shallower cleft, a shallower groove called the posterior median sulcus. Those things are good landmarks to let me know whether I'm looking at the front or looking at the back. And oh yeah, can I point something out here as well? Check out the fat that we see here. We mentioned that a couple lectures ago. This fat is found in the epidural space, giving my spinal cord a nice cushiony wrapping. Alright guys, let's keep going. What we got to do here is look at this gray matter and white matter a little bit more in this cross-sectional view. Now before we do that, check out my 3 meninges. So let's use red instead. I got my pia matter, that gray right there, my arachnoid matter right there, and my dura mater on the outside. Alright, we know this butterfly here is the gray matter. The gray matter has 2 wings to it basically, alright? And connecting the 2 wings, this is a little chunk called a gray commissure. Commissure just means, basically it's like a connection, okay? Now, on each wing, it's like there are 3 triangles. There's a little triangle on the side. That little triangle is called the lateral horn. The lateral horn is going to be motor. Lateral horn is going to be motor and autonomic. So it's going to be motor and autonomic. Remember, autonomic, you don't control. We're talking cardiac muscle. We're talking smooth muscle as well. Now, there is also a triangle in the front. That triangle in the front is the ventral horn. The ventral horn. That ventral horn, guys, is also going to be motor. The ventral horn is motor. But it is motor and it is somatic. That's why I wrote it M and an S. Remember, somatic basically means voluntary. So we're talking skeletal muscle. Okay, lastist, but not least, is the dorsal horn. The dorsal horn is going to be sensory. So we're going to have sensory neurons going into that dorsal horn. Whereas the other two horns, the ventral and lateral, those guys are going to be motor, and so the axons are exiting. Okay, let's erase all that. Now the white matter, guys, the white matter is made out of 3 columns. If you don't like the word columns, you can use this word right here. They are not only known as columns, they are known as funiculi, which means cables. I like the word cable in a way because cables, I think like electrical cables, telephone cables. And I think about information flowing. And information flow is what the white matter is all about. So, columns in the back are going to be dorsal. Columns on the side are going to be lateral. And columns in the front are going to be ventral. Beautiful. Beautiful, beautiful, beautiful. Okay, guys, let's see what else we can squeeze in this miniature lecture here. Let's look at that white matter even more. Yes, we just mentioned that the white matter has columns. And we had this other word. The other word was funiculi, which means cables, basically. Now, the white matter is further separated into tracts. And tracts are bundles of axons. A tract is a bundle of axons in your CNS. So bundle of axons in your CNS. And so different tracts may go to different places in the brain. So you may have like a spinothalamic tract going to your thalamus, or a spinocerebellar tract going to your cerebellum. All right, gorgeous. Let's keep going. Let's keep going. There we go. Oh, sorry, wasting time there. So here I see some of my tracts. So the columns are organized into these tracts. So for example, my ascending tracts in the back here, let's not do those. Let's do these tracts over here. These are both spinocerebellar, telling me I'm going to my cerebellum. This tract is spinothalamic, telling me I'm going to my thalamus. We got some descending tracts as well. Descending tracts coming down from the brain through the spinal cord. Okay, awesome. Let's see if we can get another slide out of the way. Yes, we can. We hinted at this earlier. Remember, in each side of the gray matter, we divided it up into 3 horns. There was going to be an anterior, a ventral horn. There we go. Right there in red. Notice they colored the ventral horn, or not colored, but, excuse me, wrote SM on it, because here I'm going to find somatic motor neurons going to skeletal muscle. My lateral horn is going to have autonomic motor neurons. They used a V for visceral. Visceral refers to like body organs and guts. In the back, I have S's because these are where sensory neurons are going in, both from the body and from your internal organs. And guys, that'll do it for this mini lecture.